Performance analysis of DC motor by using MATLAB Simulink. Here, this DC motor is called separately excited DC motor. So, separately excited DC motor is having field winding and also armature winding. These two windings are excited by separate. Okay, that's why it is called separately excited DC motor. Separate source, separate external DC source is required to excite the field winding and also armature winding of the DC motor. That's why it is called as a separately excited DC motor. So this field winding is fed to the DC supply. That is called field voltage is constant. So that's why field current is also constant. So field voltage is constant, field current is constant. Excitation is constant here. By maintaining the excitation is constant, we have to verify the characteristics of the DC motor, this DC motor. That is called torque versus IA characteristics, speed versus IA characteristics, and speed versus torque characteristics. These three characteristics we have to understand by using MATLAB Simulink. Okay. So here this IF is called field current, IA is called armature current, that is equal to line current, and EB is called back EMF, and RA is called armature resistance. Okay, so this is called separately excited DC motor circuit diagram. And then next, what are the components is required in MATLAB Simulink? So this is called, first one is called DC machine, and next DC voltage source, then one power guide, scope, display, so some step, bus selector, and gain. These are the some few components required to design the separately excited DC motor. And next, so nameplate details of the DC motor, separately excited DC motor. So that is called power is equal to 5 HP DC motor in this MATLAB Simulink. So we have to use 5 HP DC motor, and armature voltage is called 240 volts. 240 volts DC motor, and speed, maximum speed of this and 1750 RPM speed of this DC motor is operating speed of the rated speed 1750 RPM revolutions per minute, and field voltage is called 300 volts. So these are the nameplate details of the separately excited DC motor. And next, different torques in motors, armature torque, that is called motor torque or mechanical torque. TA is called motor torque or gross mechanical torque, and T last is called last torque due to friction. That is called windage and iron losses. TA is shaft torque or low torque, and power output is equal to torque into omega. That is omega is called speed radians per second, and these are the different types of torques. And the next output power is called 5 HP. When converted into watts by multiplying 746. You will get power output is in terms of watts 3730 watts. We know omega is equal to 2 pi n by 60, 2 pi n by 60. So it is converted into radians per second, then 183.16 radians per second. Okay. The next, power is equal to torque to omega. Here speed is called 750 RPM. Okay. By that is can be converted into radians per second. Power is equal to torque into omega. The power output is equal to, and then torque, shaft torque or low torque is equal to power output by omega in radians per second, and then you will get 20.36 Newton meters. 20 Newton meters is called our low torque. Okay, by applying this low torque to the motor, so we can observe the characteristics of DC separately excited DC motor. And then this is called speed versus torque characteristics. Here y-axis is called speed, x-axis is called torque, and then speed characteristics, there is a drooping characteristics we can observe here. Drooping characteristics, small drooping characteristics because of armature reaction, because of armature consideration. Armature reaction is taken into consideration. That is called IA drop. Okay, so because of this IA drop, so we are you will get the waveform, small drooping characteristics. So approximately speed constant in separately excited DC motor. Then next, coming to the another characteristics, This is called speed versus armature current. Speed versus current. Here this is called speed. If it is speed and current, the characteristics are like this. Speed versus current. And then torque versus current. The speed characteristics, torque versus characteristics are is increasing like this. Okay. Torque versus current characteristics. These are the current torque versus current characteristics. Is speed versus current characteristics, and then speed versus torque characteristics. So like this. So by using MATLAB Simulink, by designing the separately excited DC motor, then we can identify this characteristics of this. Okay. Let's go to here. Go to MATLAB. Open Simulink. Go to MATLAB, open Simulink. New, press new here. New. New file open like this. So once it is open, on the screen, on the drawing sheet, press 2 times mouse left click like this. There is a search box available right here. First DC machine, MA. So writing by writing like this. So DC machine directly we will get from this worksheet from library automatically. So we will get the DC machine block already designed. Model is a display on the screen when you are writing the DC machine. Okay. So it's taking some time. Initially, it's taking some time. So wait for some time. And then, so the DC machine is open like this. This is our DC machine, separately excited DC machine. So this machine is having armature winding and field winding, and this is called load torque, and this is called bus selector. So the bus selector is having different types of components: load torque and speed and armature current, field current. Like this, we will get these elements from the M. M is called bus selector. So this is our separately excited DC machine. Okay. So machine looks like this in this way. Separately excited DC machine. Armature winding, field windings, load torque, M bus selector. So we have to connect this terminal to bus select. Okay. This then first take one DC voltage source, and place here DC voltage source. This is called DC voltage source. Here DC voltage source. Press Ctrl R. It is rotate like this. And one more DC voltage source is required to connect field winding and armature winding. First connect this positive terminal to positive of field winding, and a negative terminal of field winding to the negative, and a positive terminal of armature winding connect here like this, and here this way. Okay, like this is it is connected. This is our what is this field voltage? Field voltage excitation. Field voltage. Okay, this is called our field voltage. And next, what is this next one? Armature voltage. Armature voltage, like the right here. Armature voltage. Armature voltage. Okay, right here armature voltage. Field voltage and armature voltage. These are the two voltages. And then this is called load torque. No? So that's why take one constant and connect here directly the load torque. Load torque is here fixed. Change the load torque. Open this block. Okay. Right here, load torque is approximately for this motor according to our data 20 Newton meter. Then apply. Okay. Okay. Then apply and okay. Load torque 20 Newton meters. Connect this load torque to here TL. Okay. And then next take one bus selector. Bus selector place here. This is called bus selector. We have to connect here. Bus selector to M. Connect in this patch. Okay. So this bus selector right here. Bus selector. Next, after this bus selector, here what are the signals required from this motor? What are the characteristics we have to observe from this motor? Means by open this bus selector, remove signal 1 and signal 2, remove like this, select and remove. And here left side, first one is called speed in radians per second. Select. Speed select like this. Okay. And then select item is there, na? Select icon. So speed in omega radians per second, motor speed. Then next armature current. Then press select. Then electrical torque, Newton meter, electromagnetic torque, electrical torque. Select like this. Field current is constant. That's why no need to select. And then apply. Then okay. So like this, 3 terminals will display. Okay. 3 terminals let's display here. Place here. And then from here, connected to the display. Take 3 displays. Right here, display. Display 1. The display is called, what is this display? First, connect from here to display. Speed. So, speed in radians per second, that's why it's convert into RPM. To convert RPM, take one gain. Okay. So, by gain connected here, in between these two, connect gain, multiply 60 by 2 pi. Omega is equal to 2 pi n by 16. So 60 by 2 pi, you will get current in radians per second to RPM. Take one gain right here, gain block. Select this block, place here. This is called gain block. And right here in this expression, 60 divided by 2 pi. 60 divided by 2 pi is called, right, pi. That is the expression for convert radians per second into RPM. Okay. So like this. 60 by 2 pi. So this is our speed. This is display is called speed in RPM. Okay. Revolutions per minute. Similarly, take one display, connect to the next terminal. This is called armature current. By enlarging, it is easy visible. Speed, armature current. So this is our armature current. No need to multiply gain. Only speed in radians per second. That's why some some multiplication is required, 60 by 2 pi to convert into RPM. This is first one is called speed. Second one, this is called armature current. Armature current. Armature current right here. Armature current. The next, similarly, copy and select, paste here. Next one is called torque. This is called torque. Electrical torque. Third is one is called electrical torque. Right here, torque. Torque in Newton meters. So this is our circuit, and it will be display here speed, armature current, and torque when it is a run. So what is the voltage here? 240. Field voltage is called 240. Then okay. Armature voltage is called 300. Press apply. Okay. And the load torque is called 20. Okay. And press open this DC motor, and then parameters and configuration. Here parameters is armature resistance is called 0.6. Field resistance is called 240. Field resistance is called 240 ohms. Armature resistance and inductance 0.6, 0.012. Don't change this. Go to configuration, and what type of model is required here according to our question. 5 HP, 240 volts, 750 RPM, field voltage 300. This type of motor is required. That's why select. So already predefined models are there. So from this models, select our required model. And here, so what is the chosen model is called 5 HP, 240 volts, 750 RPM, field voltage 300. This is the rating of the motor, and then apply OK. After this, next, to display torque versus speed characteristics, so XY graph is required. X-axis is called current, Y-axis is called torque. Okay, so that's why XY graph is required. So right here, XY graph for Simulink. XY graph for Simulink. This is X-axis called our first characteristic is called speed versus torque. Speed and Y-axis, torque and X-axis. That's why go to here. X-axis called torque. X-axis called torque. Last one is called torque. Y-axis called speed. This is our an RPM. Speed in RPM. So this is called speed versus, what is this graph? Speed versus torque characteristics. Speed versus torque characteristics. And then next, select like this. Next graph is called, next characteristics are called speed versus current. Speed versus current characteristics. That's why here, right here, speed versus current characteristics. So I. Speed versus armature current characteristics. So connect X is called speed. Where is X? Here, speed is here. X-axis is called, Y-axis is called speed. X-axis is called current. So connect X-axis current. Y-axis is called speed. Okay. Here, X-axis is called torque, speed versus torque, and Y-axis is called speed. Similar way, next graph characteristics are torque, speed versus torque is over, speed versus current is over, and torque versus IA. Okay. Next graph characteristics are called torque versus IA. Torque on Y-axis. Torque on Y-axis. So first one is called X, the second one is called Y. Torque on Y-axis, armature current and x-axis. Armature current and x-axis. Armature current is called second one. This is called armature. And torque on x-axis. This is the, so like this we have to connect all elements. Okay. So after this, take one power guy. Power guy ratio for continuous. So this is the Simulink block diagram connection. And then simulate. Press simulate. It's compiling. 2% is completed. Okay. It is required some few time to complete completion of compile. So wait for some time. Here, this is called speed 2736 RPM. And this armature current is called 26.39. And next torque is called 21.37. Okay. And so like this, it will be display output of this. And then what is the characteristics? So open this speed versus torque characteristics. Then it will be display automatically without changing any modifications. Okay. The speed versus torque characteristics display on the screen. Okay. Speed versus torque characteristics, speed on y-axis, torque on x-axis. In this circuit diagram, so what is this field voltage? 300 volts. This field voltage is called 300 and armature voltage is called 240. Change like this. Okay. Armature voltage, our supply voltage, DC supply voltage to the motor is called 240 volts. And this is called amplitude, that is called field voltage is called 300. Okay. And then next, so these characteristics, here what is this speed? Because of this is connected here. And then second one, torque, speed versus characteristics, torque characteristics. Okay, this is called speed versus torque characteristics. And here, by changing these voltages, the speed of this motor is called 1758, and armature current is called 20.82, and electromagnetic torque is called 21.06. After simulating, open this XY graph. First one is called, this is called, this terminal is called torque, this terminal is called speed. Speed versus torque characteristics. Okay. Open speed versus torque characteristics, and then it will be open like this. Automatically, it will be adjusted. So like this, speed versus torque characteristics are way separately exerted DC motor. Speed versus torque characteristics like this. Okay, this is called speed and this is called torque. Small drooping characteristics, and here this is called torque. Low torque here up to approximately, if it is low torque is 95 Newton meter, the speed is almost to 0. Okay, when the load is increases, speed is decreases. The low torque increases, speed is decreases. Okay, so this is about speed torque characteristics of DC motor. And then next coming to the next this terminal, where is this connected? Armature current. Armature current. Next this terminal, speed versus armature current characteristics. Open graph one, and then speed versus armature current characteristics will be displayed. Speed versus armature current characteristics. Automatically it will be displayed like this. Speed versus armature current is also drooping characteristics. Speed versus armature current. Okay, approximately constant, ideally constant, but practically this is a drooping characteristics. So we can get from this. Okay, speed versus armature current characteristics. The next coming to the next characteristics, this where it is connected here, armature current IA, and the next terminal torque versus IA characteristics. Open this torque versus IA characteristics exponentially increasing like linear. Okay, torque versus IA characteristics like this. This is separately excited. Okay, like this fashion. Torque versus in this way. Torque versus IA characteristics of separately excited DC motor. So like this, we can analyze the performance characteristics of a separately excited DC motor. Okay.